1 on the worksheet. This is find the area between of the region bounded by this curve y equals 2 minus x squared and y equals x squared. So you'll notice on some of these, they're going to give you the bounds. They're going to say starting at this x value, ending at some other x value. On some of them, they're not going to give you the bounds. If they don't give you the bounds, then that means that the functions have to intersect each other, right? If they don't intersect each other, then there's no area to find. So you will either be given them as they are in this problem, or you won't. And if you're not, then you're going to have to find what they are. But that's not that bad, because if you want to find where two functions intersect each other, you just set them equal to each other and solve, right? And then they have to do that in at least two places in order for us to be able to do this. All right, so let's see. Usually it helps to graph these when you're trying to figure out what the area is going to be. Let's think about what these two functions would look like. 2 minus x squared, parabola opening down, y-intercept of 2, so it's going to come down like that. And then the other one is y equals x squared, it's a parabola opening up, so something like this. So this is y equals x squared, and this is y equals 2 minus x squared. Now they're telling us to find the area between these two curves between 0 and 1. That's why I started at the y-axis. And then up to 1, well, it turns out that they actually do intersect each other at 1. So if you plug 1 into both of these functions, right, if you plug 1 in there and there, you find that you get 1 in both situations, right? So that means this right here is actually the point of intersection. What we're looking for is this area right here, then. That's what we're after. What is that area? Okay, and then, so how do we do that? Well, again, with this formula, you have to put the bigger function first. Bigger, by bigger I mean like bigger y values on the interval. So like on this particular interval, this function here is the one that's higher up on the y-axis, right? So that's the one we would want to put first. So we'll put 2 minus x squared first, minus, so that's the f of x function, minus the other one, minus the g of x function. That's what we need to do then. That's the interval we have to find. Okay, so that, let's simplify it and then find the antiderivative. So this is 2 minus 2x squared. So that's the integral that we have to find. Again, you can kind of see, again, when I said you got to know how to do your calculus from calculus 1. Well, here we go, right? We got to remember how to do these integrals. So the antiderivative of 2, 2x. The antiderivative of 2x squared, 2/3 x cubed. Plug in 0, plug in 1, subtract them. Well, if I plug in 1, I'm just going to get 2 minus 2/3. And if I plug in 0, I'm just going to get 0. So that's it, right? So 6/3 minus 2/3 is 4/3. So 4/3 is the area between these two curves on that interval from 0 to 1. Okay, any questions about that one? All right, well, if not, we'll go on to the next one. Feel free to stop me if you do have any questions. I have a question you might be thinking. What if, or how do you tell which function is the bigger function on the interval? How do you tell? Well, you can either graph them, and that hopefully will make it obvious, or you could alternatively take any number that's on the interval, right? Like you could pick 1/2, say. And what if you plug that number into both functions? Well, the output of the bigger function will be bigger, right? And so that's what's going to tell you what the bigger function is. Plug in some number that's on the interval that you're given. Okay. Now here's another question. Suppose that you get it backwards, right? And you mess it up and you put the wrong function first, and then you try to do the integral. Well, of course, you're going to get an answer, but what's your answer going to look like? Everybody follow what I'm saying? Suppose you put the wrong function first. Yeah, you're going to get the negative answer, but it's going to be the negative of the correct answer, right? So you just to point this out, you will never get a negative answer on this problem if it's set up correctly. You'll never get a negative. So if you do get a negative, chances are that's what the problem was, that you have the functions switched. And in fact, if you want to, what you can do, like another way to view this formula is just to say, well, I don't care which function's first. I'm just going to say that the area between the two curves is defined like this. Right? You could do that. And if you want to do that, that's perfectly fine. You could just take the absolute value of the integral. Okay? So that's a way to around this, figuring out which function's bigger. Just say, I don't care which function's bigger. I'm just going to find the integral, put one function first, put the other one second. If it's negative, I'm just going to make it positive, and that'll be the answer.